Good day everyone, welcome to another tutorial, and today we'll be treating mathematics and we'll continue from where we stopped from our last video under Development Limited, and we'll do a petit rappel before we start solving questions. So when we say a function admet en DL à l'ordre n, we say a function admet en DL à l'ordre n if f of x is equal to a0 plus a1 of x plus a2 of x raised to the power of 2 plus a3 of x raised to the power of 3 up till it continues up to an of x raised to the power of n plus x raised to the power of n of epsilon of x. Those that are just joining us, you can check the card above or description below and you see the lecture that we already had on this. And we said that the limit of epsilon of x when x tends towards 0 has to be equal to 0 for it to work. If not, you have to do like some astuce, or you have to break down the formula again for you to be able to get epsilon of x to be equal to 0, which there's no problem. We are going to do examples like that as well. Another remark is, we said in the previous video that instead of using limits when x tends towards 0 of epsilon of x equal to 0, we can as well use petit e de x puissance n. It's still the same thing. So we're going to solve examples from this. Our first exercise, we're asked to give the DL of voisinage de 0. Same thing, we explained voisinage de 0 in our previous video. So we're asked to give the DL of voisinage de 0 à l'ordre n equal to 0, n equal to 1, n equal to 2, n equal to 3, and n equal to 4 of a function which we define as f of x is equal to 1 plus x plus 2x squared plus x raised to the power of 3. This is greater than or equal to. So we have to prove if this function is a DL, as well as if it is a DL, we should give its order at n equal to 0, n equal to 1, n equal to 2, n equal to 3, and n greater than or equal to 4. So before we solve it, like I'd advise you write down the formula again. In that way you'll be able to see clearly what your A0 is, what your A1, A2, and the rest, what they are. So okay, I have a small board, so I think I'll be cleaning from time to time. Okay, so we set a function again admet en DL à l'ordre n of voisinage de 0 if f of x is equal to a0 plus a1 of x plus a2 of x raised to the power of 2 plus a3 of x raised to the power of 3 follows the same order up to a n x raised to the power of x raised to the power of n epsilon of x. And we say epsilon of x tends vers 0 when x tends vers 0. Okay, so we're going to start with the order of 1 of 0. So when n is equal to 0, what happens? Remember, if you look here, you see that the general formula for this function up to the order of n is an x raised to the power of n. And so if we make n to be equal to 0, if n is equal to 0, this will be a0 x raised to the power of 0. And we know that anything raised to the power of 0 is going to give us 1. So 1 times a0 will be left with just a0. So in this case, if we bring back the function from the question that we are given, they said 1 plus x plus 2x squared plus x raised to the power of 3. So if we are to put the n equal to 0 and n raised to the power of 0 is 1, so we're left with 1 times a0, and so we'll be left with just a0. So in this case, our f of x will be equal to a0. And a0 is a constant because this is a polynomial function, as you can see, because it's going in like in increasing order. That is our x. So that means if a0, this is a0, I don't know if you can see it. This is a0, this is a1 of x, because here there's a certain constant with x, in this case is 1. This is a2, x raised to the power of 2. This is a3, I think I should use the blue marker. This is a1, x raised to the power of 1. This is a2, x squared, and this is a3, x cubed, where a3 is a constant here, a2 is 2, and a1 is a constant, which is 1 in this case. So that means our a0 is equal to 1. So the DL allowed n equal to 0 of voisinage de 0 is 1 plus x epsilon of x. So this is 1 plus, so that means now what is epsilon of x? Epsilon of x is the rest from the polynomial function. Like if you are given an order to get to, if you get to that order, any other polynomial left from the function, we take it to be our rest. So in this case, our rest will be x plus 2x squared plus x raised to the power of 3. And the good part about epsilon of x is that every time you don't have to keep writing the rest exactly what it is, like the x plus 2x squared plus x raised to the power of 3. We can just denote it as epsilon of x. So here, we'll come back here. If you look here, you see, remember we are saying n is equal to 0. So if n is equal to 0, again, anything raised to the power of 0 is 1. That's anything raised to the power of 0 always give us 1. So that means this is 1. 1 times epsilon of x will give us epsilon of x. So we are left with epsilon of x. Again, another thing to consider is, now this is our epsilon of x, but our epsilon of x is the limit equal to 0 when x turns over 0. Remember I said if it's not, then you have to do like, to look for a way to make it to be the limit to be equal to 0. So x plus 2x squared plus x raised to the power of 3, the limit when x turns over 0 of epsilon of x will be equal to, if x is equal to 0, when we are calculating limit, in this case what they mean by x turns over 0 is replace your x with 0. So if I replace this with 0, I replace my x with 0, I replace my x with 0, I'll be left with 0. And so it verifies the condition that says the limit when x turns over 0 of epsilon of x has to be equal to 0 for it to work. And so in this case, the limit when x turns over 0 of epsilon of x is equal to 0. And so we've been able to prove the first part, that yes, when n is equal to 0, this function that we've been given admit and dl. Now, that's for the first part. Now the next part is for when n is equal to 1. We apply the same principle. Okay, I think we are running out of time already. The next video will continue from when n is equal to 1 up until when n is greater than or equal to 4. So thank you for watching and see you in the next video.